Okay, well, while I get all this set up, I'll tell a little story of the first time I actually realized just how important this stuff is that we do with the Xen Project. I've been with the Xen Project with the XenServer team for just over 10 years. In 2016, you remember there was the Rio Olympics. So I remember about a month before the Rio Olympics, having a panicked engineer come to me saying, look, there's a big problem. Air traffic control for Rio Olympics is on the line. They want us to fix their hypervisor. And so we had this poor guy sit there for, I think, about 2 or 3 nights, day in, day night, trying to sort this problem. So I like to think that we actually solved made sure that the Rio Olympics happened. And I'm kind of waiting for the Paris Olympics to give me a call. So if I do get a call, I may have to take it, just in case. All right, so let me get this going, and then we can start. There we go. All right. Right, I am Jacus de Beer. I'm the general manager for XenServer business unit. I'll talk a little bit about what that means in the rest of the presentation, but really today I want to take you a little bit behind the scenes. Of course, no, this thing doesn't work. There we go. Behind the scenes, right. I want to give you a little bit of a peek behind the curtain. What does that mean? Well, I want to show you a little bit what it takes. We all know about Xen, the Xen Project, the Xen Hypervisor. And I often get this thing where people tell me, oh, you just repackaged the Xen Project. Well, in fact, there's quite a lot that goes on to make the Xen Project into something that an air traffic controller can actually use and trust. Right. So we're going to take a little bit of a peek behind the curtain. We'll talk a little bit about what do our customers actually look for. We're going to talk about how do we deliver that to them, what are the things we need to do to make sure that we're happy with what we deliver, and also what are the external factors that contribute to our success. How do we actually make sure that the whole thing works together as a unit? Now, I'm good, everybody is sitting down because the next part is going to come as a shock to most of you, so please bear with me. Unfortunately, most of our audience find hypervisors exciting as air conditioning. In fact, they don't care about it at all unless it doesn't work, right? That's when they start caring about it. They really want to focus on their business. What is it that they're doing, whether that's healthcare, whether that's manufacturing, financial services, that's what they care about. They don't care about how their things run, they just want it to run. Which means we have to make sure that, and of course, most of our customers do not have any Linux experience, never mind hypervisor experience. So we've got to be a little bit, shall we say, accommodating when we give them something to work with. I'm saying our customers, your customers may be different. Right. So our hypervisor should not require specialist knowledge. It should be secure by default. This is something we're very good at. We actually err on the side of security rather than on performance. Some other hypervisors do it the other way around, but we know our customers, so we go for security first. And should be simple to maintain. Right. Now, staying secure really matters. And some of our customers are security conscious. Some of them are security unconscious, but that's a different matter. And some of them are very, very security conscious, very worried about every little thing that's going to happen. So we've got to be careful with that. We've got to keep an eye on that. And we've got to break out this thing. So we generally work very closely upstream. You may recognize some of these cute cartoon characters on the side here. Some of my engineers spent multiple years of their lives getting rid of those 2 little characters, Spectre and Meltdown, for those that don't recognize them. We typically fix issues right at the embargo date or right just after embargo has lifted. So when we have a security issue, there's an embargo date. We generally release right on the date. Sometimes we miss it a little bit. But so does the Xen Project, right? So Xen Project provides patches at the moment of embargo. But of course, our customers, we've got to package those, make sure that they can handle them and can deploy them. Right. So how do we keep our customers safe? They have to stay within an envelope. We tell them, what are the kind of things what are the configuration limits, what are the supported hardware, network configuration, security best practices, etc., etc. And the result of us constraining what they can do actually means that we have fewer things that they have to worry about. So if you look at just 2024, we had 10 upstream CVEs, 10 XSAs covering 10 CVEs, but we only had to do 4 for our XenServer customers. So we look at the CVE, we decide, is it relevant, does it matter, does it impact our specific customer use case, yes or no, and only if it does, then we have to supply something. Now, of course, the next big one is time equals money, and in our case, for customers, downtime equals money. If you are an emergency room or if you're a financial services, you cannot afford to have downtime. They don't like it, they don't want it, and there's no good time for maintenance. They don't like doing this at all. Right. Now, ironically, the thing that makes a hypervisor really valuable is also the thing that makes it really expensive to reboot a hypervisor. The more VMs you run, the more workloads you run on a hypervisor, the more expensive it is to actually shut down that hypervisor and restart those workloads. So, and of course, that means our customers delay doing security updates, and of course, that increases their risks. So be aware of that. We try and minimize the downtime, live patches wherever possible, VM migration for pool updates, and then guidance for what they do and when they have to do it. They also want stability. They do not like this box where we start pulling out the bottoms, which means we have to avoid patches, upstream patches that introduce risk. I'll talk a little bit about just how big our patch queue really is. We maintain a little bit of a separation between us and the Xen upstream. New features should not disrupt existing use cases. So even if we've got this new shiny thing, does it impact an old existing use case? We've got to think about the migration paths. How are they actually going to get there? And also the upgrade impacts. What's going to happen if they update something? And of course, always data integrity. You cannot lose a customer's data. You cannot just corrupt his data. They get really upset if you do. That means our upgrades need to be fault tolerant and recoverable. So you can't just have if something goes wrong, you've got to know what it is and be able to recover from it. Right, so how do we as XenServer deliver this to our customers? Well, I'll start with our labs. Now I love this one. This is our current lab situation. We've got 1,728U. Now I like to think of this as one big rack going all the way up, right? But actually, it's over 30 racks in 2 data centers that make this up. 14 kilometers of cable. That's a lot of cable. Copper, fiber, Ethernet, power. 130 kilowatts of power, in fact, that we use, peaking up to 170 kilowatt. We have capacity for up to 250 watt. And this is just to tell you, this is so that we can replicate the environment our customers run on. So we have a chance of saying, okay, this is similar to what our customers actually have much bigger deployments than this. So this is us trying to approximate what they do so that we can test and validate. 1,373 devices. That is servers, network cards, net apps, anything you think of, power supplies, the whole works. 210 network devices, up to 100 gigabyte. And then this allows us to do roughly 800 test runs a day, up to 3,000 test runs a day when we really, really need to. This is how we do it, right? So test automation is the key. There's no way we can run through this, we can work with this without actually having the test automation in place. And it's a massive challenge to test at scale. It's not just that we test at scale. Most people set up their environment once, then they run it for years and years and years. What we do is effectively, every time we run a test, we set up the environment from scratch, run the tests, break it down, set up the new environment. Of course, with this amount of hardware, what typically happens is we have a test failure, but it may not actually be a test failure. It may actually be a physical hardware failure. So we have to look at triage, understanding what the issue is and how we can minimize the impact of hardware failures when they happen. Of course, different product versions also have different results in the test, so you've got to take that into account. And no matter how much automating testing you do, the problem with automated testing is you're always testing something in exactly the same way. So you need to add some manual testing where you try things in the crazy ways that our customers do them, doing the thing that they absolutely should not be doing. Try that manually and see what happens. And of course, every time we have a test that fails, when we have a customer that comes out, we try and do a test escape analysis to see why did we miss that? What was the thing we could have added that would have given us the ability to pick this up ahead of time? And then we try and add that in. This is only possible through the automated deployment, installation, and test of our very impressive XenRT system. Now, this has been developed over the last 20 years alongside the product. It does job scheduling and result maintenance, so it's effectively a test harness, but the test harness that does full deployment, running the tests, validating, collecting the results, and reporting them. Supporting a large variety of Windows guests, and it is a first-class software product. So this is as much a product for us as anything else. We have unit tests, we run it, we go through static code analysis with it. It's massive. It takes an engineer a couple of months to learn to actually contribute to it. So just so you know, that's what we do. I'm not going to go into this, but we do every single kind of test you can possibly think of, anything from unit tests to long-term scale tests. How many tests do we run? Well, since 99% of tests are automated, we run, on average, 250,000 jobs per year. Now, a job is just one test run, which means it actually contains multiple tests. Right, so that's kind of what we do. And then we've had a recent milestone in May. We've had 4 million jobs run, test jobs run over the lifetime of XenRT. So just to give an idea. In addition to just the normal tests, we also have recently added some open telemetry stuff. I'm really happy about this. This is really exciting, and you should really, maybe there's a design session about this. If there is, please, I would highly recommend going to this. This gives us visibility of what actually happens right down all the way through the Xen layers. This is something that's really exciting. If you've ever done any kind of performance analysis or trying to find a tricky bug where you don't understand how things interact, or if you're just new to the project and you want to learn how the different pieces interact with each other, this is a great place to look for. This tracing gives us the ability to see which parts of the system is calling which, what are they doing, how long are they spending in there, and what are they doing. So you can see things are running in series when they should be running in parallel, etc., etc. All right. Our classic testing is just keeping track of, we have a massive database of test runs as we've gone through. So as we go through, we keep track of these. And this is an example of where we picked up a regression. So somebody committed a change. For some reason that had a regression, took us a while to find it and then fix it. But once you fix it, you can see again that you fix it. So this is a very classic example of ongoing testing and what that gives you. Different hardware, different sizes, etc. And then, of course, this is all open source. You can use other open source tools to evaluate and see what the output is, to monitor it and get the metrics you need. We've recently also added a continuous release model. So this is an ability for us to actually push data out to our customers much more quickly. I'm going to do these out. So effectively, this is a pipeline, our release pipeline. So this is not, we have got processes ahead of this, but this is the release side of it. Once we've done the testing and we're happy with that, it can go out. We have several stages that it goes through, and in each stage, there's additional testing that happens before it goes out. So dev team is our internal. The developers work together, different teams get the access to the new released code. Internal is within our company. There are other teams that actually use the hypervisor, so this is the first time they get it, so they try and get the early access to it. Early access is for our customers, so if you are a customer and you want to have an early view of what's coming up, you have a test lab that you want to actually try out, or if you just want to be the first to have all the greatest and best features, then you go on to early access, and then normal is just where our regular customers pick up their. Of course, we also have something called a high priority push, where if we do have those security hotfixes, at the embargo date, we can push a fix out to all of these stages at the same time. All right, so what external factors actually contribute to the success of the hypervisor? Let's have a look. There are a lot of things that actually sit around the hypervisor. It's not just the hypervisor, it's not just the OS, but to make it successful, you need provisioning solutions, you need the guests, the OS vendors need to support that. You've got storage controllers, you have shared storage, you have lots of hardware that you actually have to run with and support. Now, of course, our biggest and most long-standing partner is the Xen Project, right? Give a little bit of history. XenServer and Xen Project has a long history together. In fact, Xen was originally a Cambridge research project, as Kelly mentioned. First public release of Xen was in 2003, with version 1.0 in 2004. So that's literally 20 years ago. That was spun out as a startup called XenSource in 2005, which was then acquired by Citrix and called XenServer in 2007. So that's the kind of where it came from. XenServer or Citrix then spun out the Xen Project, so the core hypervisor, as a Linux Foundation project in 2013. And then most recently, Citrix was acquired by a company called Cloud Software Group. So you may see Cloud Software Group there if you don't know what that is. Cloud Software Group bought Citrix. We're now part of this. Citrix is now a business unit within Cloud Software Group, and XenServer was broken out specifically so that we could focus more on what XenServer does and to make sure that it has the resources it needed to be successful. Right. Now, talking a little bit about the patch queue. So I know that you think we do just repackage the hypervisor, but this is the truth, right? So from our integration bonds, we only have about 7 patches, 7 integration patches, 30 bug fix patches, and about 39 feature patches. Now, why do we keep patch queues? Why don't we just upstream these? There's many reasons, right? For some of these, it's not relevant to the rest of the upstream community. They don't want the patch, so we keep it internally. For some, it is the changes we have is less risky than the changes that's currently published. We try and stay as close as we can, but this is where we are at the minute. Of course, our XenServer 8, which is the latest version of XenServer, is based on Xen 4.17, which has that patch queue and then 87 backports. So again, remember stability. Our customers care about stability. We try and keep the versions the same, so we do a lot of work to maintain the same kernel, same hypervisor, but that does mean when we have security fixes, when we have critical features that needs to be added, we have got to add some backports onto that. But that's nothing against our 8.2 CU1. This one threw me. Patch queue and 352 backports. So this one is a bit of a beast. June 2025 is end of life for this, so I'm holding my fingers that we can keep to that and get rid of this one. Of course, we continue to contribute to the project. Just some of the security features we've been working on, speculation work, talk about Spectre and Meltdown, they keep haunting me. Shadow stack, indirect bounce stacking, you name it. I'll let you speak to Andrew Cooper about any of these, as he politely provided me with these slides that, yeah, I understand about the first word of, so that's good. All right, so in addition to the Xen project, we also work very, very closely with a number of partners. This is the HCL is our, I'm going to forget what HCL stands for. Hardware Compatibility List. Thank you very much. There we go. See, I was just testing whether they were awake. This is what we do is our partners, our hardware partners certify that they work on XenServer. So they run a test, we give them a test suite they have to run, they run the test, we certify the results, and that means they get listed as a supported hardware platform. Now this gives you an idea of just the sheer scope of the number of people that actually contribute. I don't go into the detail, but you can see Lenovo, Fujitsu, HPE, Dell, Supermicro, number of names are very familiar there. And what types? Mostly servers, but also storage controllers, network interface cards, GPUs, and CPUs, new CPU versions as well. I'm not going to read into this. These are just the models of servers. So if you just look at the server side, Lenovo by far the biggest, HP, Supermicro, Intel, Dell. Each of these are relevant. And you have to understand, talking to each of these partners is not about they just certify it because it suits them. It means we have to have a relationship with them. We spend a lot of time. Clifford's team is very busy with that. They actually spend time with each of these partners. We have monthly or bi-monthly or meetings with these guys, talk through the issues, understand what they need, what they want from the hypervisor, and how we can actually help them to run on top of it. And then, of course, third-party drivers as well. So we have drivers that have to run on top of this. Again, the hardware vendors will provide us with the drivers. We try and get them to at least build the driver before they send it to us. That doesn't always work, unfortunately. They tend to just give us what they have. But we work with them, and then we send it back and say, look, you've got to at least make it compile before you send it. All right, thank you very much. And then, we try and incorporate that. So that allows us to put some of the drivers directly in. We publish driver disks and things like that, so people can make sure that their hardware actually functions properly with the software. And then finally, just all the guests. We add a large number of guests every year. We continue to do that. Most recently, we've added UEFI support for Linux guests as well, so made sure that that works. That's an ongoing process that needs to keep going all the way. All right, so I've talked a lot about many things. This is just literally just a peek behind the curtain. This is not everything we do. I haven't talked about all of the updates and security fixes we do and things like that. But for today, just basically 3 key takeaways. First, for the audience, when you think about making a change, consider the impact it's going to have on other pieces of the code. Think about stability. Think about how is this going to actually impact what the person is doing, right? For actually testing the code, one, please make sure the code's testable. That's very useful if that is. If you can actually have an example test, that's great. Kelly talked about having the CI infrastructure. We're working on that in the Xen project itself. Contribute a test as well as the code. That is really, really, really valuable. It does a couple of things. It shows people how you intend the code to be used. It also gives a valid way of saying when it's broken. So any test you can submit, please do. And then finally, remember that we have third parties that interact with this code. That means create the APIs, make it simple for people to write their drivers. Think about the third parties as you actually work and run through the code. Thank you. That's it. I'm not sure if we have time for some questions. We do, right? Got a few more minutes. Is there any questions that anyone want to ask? I can actually take a few questions. Sure.
What would it take for you to get have you told that the GPU acceleration for guests is not in the security supported envelope? What would it take for it to get in there?
All right, just repeating the question. What would it take to get GPU support, GPU acceleration into the security supported envelope? You really should ask the security team this, because I'm probably going to answer them. A lot of it is you've got to make sure that we have the relevant tests available for that. And I don't know, where's anybody on the security team? Do you want to take this?
As much as anything else, it's what NVIDIA are willing to support with us. And that is as much their choice as it is ours.
Right, so just repeating the answer. So a big part of that is what NVIDIA is willing to do with us. We are trying to improve our relationship with NVIDIA. It has historically been good, but over the last couple of years, it's kind of faded a little bit. They are wooing other bigger players at the minute. But we are trying to work on that. Once we can actually get that relationship back on track, we definitely want to do that. Any others? Yes.
What is the process when you immigrate in your upstream
sorry, just to repeat that, are you asking how do we make sure that the upstream Xen that we use is stable for our customers?
Yeah, when you
Migrate to a new version. Okay, very good question. So a lot of testing goes into that. One of the things we do as part of that, we do keep a version of the upstream Xen running as well, and we run tests on that already, even before we actually do work with customers. So part of what we do is keep that running, make sure that we actually have find any issues there, we try and fix them ahead of time. And then we spend an inordinate amount of time with migration paths. A lot of testing is about how do we go from A to B. And yes, there's a lot of, there's some very, very big challenges, not just with Xen, other things as well. Storage, if you've got changes in CoroSync, I think is one that has a big problem coming up because they have incompatible change between the two versions. So how do you manage that? So the answer is we do a lot of testing, we do a lot of pre-validation on that. We run the paths that our customers will run many, many, many times to try and make sure that we find any of those issues. Do we always get it right? No, we don't. I've been in a couple of releases where we've pulled the release very quickly because something cropped up on a corner case that we just didn't cover in our testing. So then we respond very quickly. So there's always a little bit of when the new thing goes live, everybody is like, okay, we think we've tested everything, we hope we've tested everything, but people use it in ways we don't expect. They use it in hardware that one is way out of support or very different from the hardware we've actually tested on. So that's a hard problem, and it's a continuous problem. So good question. Right, I think if chance for one more question, then we'll call it there. Okay, if not, thank you very much. Really appreciated it and enjoy the day.